job today. Today we mill pockets into this lower motor mount of a Forte bandsaw to be able to put axial bearings, which are these here, and the bearing surfaces, to put them in here and on the opposite side. So whenever you want to adjust the cutting speed, a screw goes down here and you turn a knob and this thing goes up and down, which then takes the motor, which has a cone, and the gearbox, which has the opposite cone, forces it down into the cone or out of the cone. And this way you adjust the cutting speed from low to high. And to make it easier to turn a knob, so originally there's just a washer in here and two nuts, and the washer and nuts turn on the surface of this motor mount. To make the adjustment easier, we put in two axial bearings. So on each side a bearing, then we can adjust the tension with the screws, because there's a step on the bolt or screw that comes down here. The step will push from this side, and on the other side we can adjust with the nuts on this screw or bolt or hand wheel the tension of these axial bearings, and then we're going to be fine. It's going to be easy to adjust the cutting speed then. For this operation you're going to use the Bridgeport mill and a boring head. So let's put you over here so you can see what I'm going to be doing and get to work. At first we're going to remove the vise. The screws are already pre-loosened. I unloosened the screws, as someone else would say now. And take this out. Remove the vise. I'm just going to go ahead and put it on the other milling machine for now. I know you can't see that, but I do that. And we go ahead and clean this table a little bit from all the oil and residue. Crank the table out to make setup a little bit easier. As there is not that much precision required in here, we will just put it straight to the table, bolt it down with some strap claps. I use the T-nuts. I normally clamp the vise with. You go ahead and use them. And I'm not going to bother setting a stop or anything. I mean, we have a DRO in this machine, so we're just gonna go take an edge finder and find center. Then we make this side, flip it around, take the edge finder again, find center. Maybe we are fancy and circle it out with a dial test indicator, but as I said before, there's not much precision required in here. There is no bearing that fits perfectly, and this is just a motor mount. It's not any type of very fancy fitting or stuff. We don't have to be that extremely precise. Well, unfortunately, I don't have any longer ones, but I have, they don't fit. I want to say, but I have not as tall strap clamps like the ones, but therefore M10, so don't fit the M12 bolt. Should have thought about that as I grabbed them, but I didn't. Yeah, the thing about the bolts and screws are, you have like 100 of one size and none of any other size. It's always like that. Let's see how much thread engagement I get. Well, almost half the nut. This being a flange nut, I think we can get rid of the washer too. So we're just going to go ahead and take a washer. Now I have almost the whole nut as an engagement. So where I put the other clamp? I think I brought it back. Yes, I did. Center it up some. Take a flange nut here also. All right, as we don't have any milling to do in X or Y direction, only boring out this diameter right here, we don't have to go ahead and indicate it in being straight or parallel to anything. We just have to look that the bore is straight going up and down. That's all we need to do. We want to take, this is an M16 screw. You see, it's basically working just like this. Maybe I have an M18. No. Maybe. No, I don't. So what we're going to do is push it to one side, and where I put that one? On the press. And all we're going to use now is like just a regular square. And all we're going to do is like square it up in either direction. Look for it being at least a little bit straight. Well, it's not that straight. How about the other side? Other side is good. So you see, this is not, I know you can see it right now, but this is, better turn it around. There's some ridiculous big burr on it. Push it down the bore. This side is perfect. Let's go ahead and use this side of the bore. Perfect also. See, I'm pushing it down inside the bore on the bottom and top against the wall of the of the bore. So even though this being a little bit smaller in diameter, like this is an M16 by 1.5 fine thread, the bore being slightly bigger with 17 or I don't know, we can measure it. It's about 17, maybe a hair under. I can easily measure straightness of the bore, and that's enough for this part. I mean, you see yourself, this screw goes down here, and we're not going to have any side forces, we're going to have only axial forces. There's no radial alignment whatsoever in this screw. The screw might be bent, we don't know. So all we need to do is make axial transit of the screw going through this bore, being pressed between these two bearings easier. We don't care if it might be cocked any other way. That's why I said it's not a very high precision part and not a very high precision application also. Of course we need to make the diameter pretty good, so these bearing surfaces we can put in there then run fairly straight. But as I said, it's gonna get adjusted, and then we'll see. We're gonna see how it works out. I mean, it's gonna be at least better than before, I hope. We'll see. So all we're gonna do in alignment, because I can't help it, let's see if there's at least any surface here. We could at least a little bit align it. Yeah, there's some here. Actually, pretty straight already. That's all we're gonna do. And as I said, we're not gonna bother with a stop. We don't know if this diameter is the exact same up here and down here. So if you flip it, we just don't know. I also could say it's not a big precision part, but indicating it with an edge finder, it's going to be enough, and it's going to be very fast. So tighten this down. If we find a wrench, we do find a wrench. All right. I guess that's tight enough. Now let's come to putting an edge finder. Oh, I forgot. I'm going to put the wrench right there. Tighten it down some, so it's not falling out. We're going to use a different one. This one's better. See, this one has a 4mm tip, as the other one only has the 10mm tip. The bore being 16mm, I mean, we could easily get in here with the 10mm tip, but you're gonna see it a little bit better with a smaller tip engaged, and we have it, so why not use it? And don't over tighten a chuck when using a indicator. Let's see, what gear are we in? better. We're spinning. We're spinning at the top one. Oh, maybe that's a little bit fast. Ah, no. We're gonna spin at 660, which will be our 600 at this machine. As this is an American motor for 50 hertz, and we have 60 hertz. I don't know. I don't remember. Well, the machine all powered up. We make a little test run. Let's see. Switch it on, switch it on. Breakers out. Perfect. We go ahead and bring the table up. Yes. You will have to do this anyway. And maybe, as we didn't use it for a couple of minutes or days, pump in some fresh whey oil. So all the ways get lubricated very good for the longevity of the machine. Do the Y direction first. Maybe put it a little bit down here. Zero the Y direction. And as we're using a milling machine now, better put on some safety glasses. Now let's repeat it, so we can be sure to have 5 microns off. That's okay. Go to the other side. And what we want to do is we keep moving the table in Y direction inwards until the edge finder touches the bore, the wall of the bore. First it starts out with a very eccentric move, like these two parts are separated, and they just want to wander around like crazy. We push it inside until they're a little bit or perfectly aligned. Keep pushing, that's the important part. Keep pushing until the moment the lower part goes out sideways. As soon as it kicks out, you're right at the edge. Yeah, right now it kicked out. How are we going to find center now? Well, we have the distance from the inside or from one side of the board to the other side of the board. The middle should be right between. So we take just half on a DRO, select the axis, and we're done. We go to 0. Lock the table, which moves the table. Not very far, but a little bit. Lock the y-axis, and now do the same thing in the x-axis. I'm looking down the edge finder. Now it runs pretty much. Now it runs very much in line, and now it kicked out. We're going to zero out our x-axis. Maybe you can see it better like this. If we spin, yes, it spins already. Now, when a little bit too fast. But looking on the DRO, we are good. Yeah. Zero it out again. Yeah, there we have it. Now go to the other side. Alright. Now let's use the half function again, which is here. We select our axis, x-axis. Now we're going to continue going to 0. Lock the table. And we're on center. Alright, now we remove the drill chuck. And let's put in the small boring head. All right. Brake engaged. That's why. We can use that one. First we're going to bring it back. Oh, bring it back, I said. Bring the head back to center. Yeah, right. Hopefully we have already a ground bit that we can use. This would be fine, but it's too short, I guess. Let's see. What's the overall height of the bearing? That's going to determine how far we need to go. And we have to set a stop for that also. Like the bearing consists of 3 parts, like a washer leg part, which is hardened. This is a bearing surface. This little bearing runs on, and the washer on top of. So you see now right. So let's take some measurement. We're not going to fancy around with a we're just going to take the caliper reading, which will be fine. It's about 4 millimeter tall. 4 mil tall. Where did I put it? Yeah, lost it again. Or lost it already. No, can't use this. Can't use this either. Here it is. I think we get lucky. We might try it. It's right on size. Let's see if we would have another bit we could use, but unfortunately with this small boring head I don't do much of this work, so that looks bad. Yeah, we could use this, I think. That's very sharp also. That's more than enough. But we also might be able to use this. No. No, we can't. No, we can't use this. Right. But we can use this one. But I unloosen this screw. Yeah, let's try that. All right. We have to go down like 4 mil. And we're going to use the power feed for that. And yes, we could use an end mill in here. Maybe it would be really good to use an end mill. I don't know. But I'm not sure if I have an end mill that small. And I don't like boring way out here. I like to keep it as short and compact as possible, the table raised as much up as possible. This gives it all more rigidity. And this machine is very old and not in the best condition also, so. But it's perfect for the application we have right here. All right, now. This is as far as we're going to extend it. What we're going to do next? We crank up the table pretty far. Use something we know the thickness of, like a parallel. Like these parallels have the thickness engraved on them and they're ground. So they're really very, very close. This thing is 8 millimeter thick, 8 mil thick. And we have to remember that. Now we're going to turn it slowly and raise the table slowly. Yeah, we could also use paper or, but see, now it's moving the parallel in and out. So it's just about touching. That's more than enough of accuracy on this one. All right, so we know this distance from the tip to the surface of our part is about 8 mil. We zero out the table. We can bring this up all the way. Now we go up with the table 8 mil. 8 mil. I was already thinking ahead how far I need to go. All right, now we are up 8 mil. Now these two are on the same level, but we need to bore 4 mil deep. So we raise the table an additional 4 mil, all the way up to 12 mil. Then we lock the table, turn the handle around so we don't catch it, accidentally turn the screw or just get caught or anything else. All right. Now, you see, when I use the power feed, it's going to engage and disengage at this one here. And this is going to be the 8 mil we raise the table, the thickness of the parallel, plus the 4 mil we want to get, we want to bore out in height. So we can use the power feed without looking every time, oh, how deep am I? Do I have to measure? Nothing. We can lock all tables and now just bore, push the head out, bore, push the head out, bore, push the head out until we're done. All right, so now let's see how far we need to push out the head. And we're going to see how round this hole is in a second. I mean, you can do it different, but I do it just like this all the time. And this is cast iron, by the way, so no hot material. We can screw up our bit or anything. Yeah, it's touching around here and here, and it's barely touching in this corner, so we are pretty much on center. All right, so this boring head gets you messed up pretty quick, because this dial right here, it shows increments. You can read it on the dial right here. It shows increments, but these increments are not half the way you push the head out. They are the exact way you push the head out. So you have to remember that. When you want to increase this hole by 1 mil in diameter, and you push the head out 1 mil, you increase it by 2 mil, because you're going to take 1 mil off this side and 1 mil off this side. So you have to half the dial, or think ahead, like I want to remove 2 mil, I put 1 mil. All right, first one, we're just going to go like half a mil. Wait, to 84, let me take 40. That's 0.4 of a mil. We're gonna go ahead, close our jacket. No loose clothing and stuff like this. All good and tight, and common sense. When this thing runs, don't try to catch, grab, or do anything. Like, don't try to grab with your bare hands some filings or shavings. Stop the machine, get the head up, or the boring head out of the way. Take some pliers, or if you don't care, bleeding, take your bare hands and remove whatever you want to remove. All right. Let's see if we're... I guess that's going to be fine. I bring it in here. Let's see how quick is it moving. Let's take the smallest setting first. Alright, engage powerful. Oh, right. We should engage everything. Like pull this lever to in position. Take the desired depth we want to take per revolution. Like this is the smallest one. We also need to tell the machine which way we want to go. Down or up. Right now we're going up. We better go down. That's it, go down. Sometimes it's a hassle. Let's see what's going on. Now it fits that. Right now we can just step back and watch. Not maybe. Be close to the off switch. That's not. A little bit fast, but I think it's going to work. Alright. And now that's the nice thing about the DRO. I want to take a look. I just crank out the table. Some more. So the head's not in the way. What we got here? Unloosen the table, adjust it, one more. Table back, crank all the way to 0 again. Yeah, that's gonna be fine. All right. Let's do another one. And measure again. Some more. That should be fine. Try to catch that ridge. Yeah, that's fine. A little bit too much, but we don't care. It's like if it would be fancy, we could later take our 1/2 and bore or face this here. We could. maybe we're just gonna go ahead, take an end mill right on the bridge port. Too far. Mill there. Alright. What didn't we do? We forgot to clamp the head. Alright. We go ahead, take another 40. Then we're at 0. This time we don't forget to clamp the head. And get our part through. This being cast iron, we don't have to use cutting oil or any other fluid. It's self-lubricating with all the graphene in it. We just don't have to care about it. Alright, should be good enough to take a measurement with a caliper. Yeah, we could be fancy, use boring gauges or snap gauges or so much other stuff. But we don't have to. 16, 17, 19 mil. All right, now we know we have accomplished a diameter of 19 mil. And we need a lot. We need almost 30, 29.9. 29.9. That's what we're gonna need. Let's go ahead and write this down. We need 29.9 in diameter. We had, let's measure it again, so we make no mistakes. We have 20.1. Let's measure it again, because last time we didn't have that much. Just the bore around here. Getting inside the bore would help. Yeah, right. 20.1-ish. Not completely. So now we know we have to increase this diameter by 9.8. 9.8. That means on our dial, and this is why I dialed to 0 right now, or the last time we took, now we took off 2 times 40 on the dial, which is 80 on the dial, which is 1.6 mil in diameter. But we're at 0 at the dial right now, so it's easy. 9.8 is what we're gonna have to take out in mil, 9 mil, and almost one more. This is gonna be 4.9 on the dial. All right. We unloosen the head. Take another 50, or take 50 this time. Engage it. Go down almost before it touches. Yes, we're at 0 everywhere. Another. And this is going to be a rinse and repeat action. Go to 0, clamp it, engage it, engage the power feed. And now what I like to do is, I want to make me a mark, like 1. Now I removed 1 mil. No, 2 mil. And what I want to do is make me a mark. And what I do is make me a mark. Like last time we completed a full revolution, so I make me just like 1, and I continue doing this. Like we need 4 revolutions and almost 1. Don't get, this time when I get distracted, like I have to make a break because somebody's coming in, phone call, whatever. I have my marks here, like 1, 2, 3, 4 full revolutions, and I can look. I'm either at 50 or 0. So either I am at that revolution or I'm halfway more. Easy as that. And rinse and repeat. Better take a brush. All right, now we took out about 8 mil in diameter. There's a brush. Now that's a very nice bore. I made 4 marks, so we are already removed 4 revolutions, which on the dial is 4 mil, but these are 8 mil, so it's about 1.8 mil to go, or 0.9 revolutions. But to be sure we don't mess up, we take another measurement. Right now we're at 26.4, about 26.4. Am I reading that right? Yes, 26.4. We need 29.9. So it's even 3 mil more to go. So 1.5 rotation. All right, let's see. Take another measurement. Yeah, 26.5. 26.5. All right. 26.5. Now we're at 27.5. $27.5 we had. Now 29.5. But to be sure, we're going to check again. $28.1, 29.1. Yeah, right. Very good. Yes. Clean the brush by throwing it on the ground. You can do this. All right, let's clean out, get a little bit better measurement. Because all the chips might make you look you're too small. You remove the chips and you're way too big. That happens if you don't clean up. All right, nice. 28.45. 28.45. But not here. 28.50. Well, okay. 28.50. So we can this should get us to 29.50. Cool, about. Now this time I did it different. Why did I do it? I don't want to scratch the surface all the way around. I'm going to take it back out, like put in a spiral pattern. I didn't do it before. I'm going to need my vacuum here in a couple of seconds to get rid of all the dust. Yeah, right on size. Fine, we're done. Which means right now we can zero out the table. It's easy. We retract our boring head. Retract, I said. Alright, we have to clean up the bearing. If you would remember where we put the 19mm wrench, that would be nice. Maybe somebody sees it. Yell at the screen if you can see that wrench. Good thing 3/4 of an inch is about 19mm. So it fits. But it's not the right one, so I don't like that. Alright, let's take out the part. We're going to go ahead and deburr it real quick. Maybe this works. Maybe not. No, it works. Would help if you actually lock this real good. Then you don't lose it during deburring. It's not like I want to put a very massive chamfer on it, or there's also not a massive burr. But I don't like a sharp surface to scratch this table. I mean, obviously this table is old and that's how I got the machine, all bent up and yeah, not how I would like it, but at least not put in more dents and scratches and stuff. Look at this. This is everything then a flat surface on the other side. Everything but a surface. Look at this. This is everything but a flat surface on the other side. We just poured out. Where did I put the gauge? How does it look like? Oh, it looks bad. I need to loosen this one. Still can't find the wrench. Well, that was too much. That's good. Let's look at this side. Fair enough. All right. We put our hand on it, so we might be able to feel when it starts cocking again. And it rocks a little bit from side to side. A little bit more on the left side. So let's go ahead and do this again. That's fine. I can see a small deviation, but not that bad. Yeah, more here. Way more here. We need to put a shim under it. There's the wrench. Let's put this in. That's 0.15 of a mil. Maybe this helps. Let's see. Oh, cool. I don't like it. Little bit more on this side. Yeah, fine. Way better. Oopsie. Yeah, it moved a little. It's amazing what you can feel with your fingers, like on a surface plate. You clean it with degreaser and everything. Just let it sit like a second or 2 or 3. And look at it again. It looks perfectly clean. You walk over there, take your hand and wipe it, and you feel, oh, who cleaned that? All right. Now centering that back up on the board. And as I said, it could be very fancy and all that, but it's just not required, so we don't do it. And don't over tighten it. This is just a hollow tube where a spring is in it, a tension spring. So if you over tighten it, you damage the edge finder. And you don't want a defect or damaged edge finder. Not at all. Oh, look at that. We are so far off. All right. So when you're using the mill in a different setup in the morning, it's hard to overcome. It's fine. Fine. This hole is even bigger on this side. Maybe it wore it out some, or I don't know. finder again today, or at least not on this mill. We put our boring head back in. Then again we need our parallel. Where did I put it? Right here. All right. We zero out the Z-axis and take another 4 mil. All right. What did we do wrong? We need to take an additional 8 mil of the parallel. I forgot that. Yeah, right. Now it looks right. All right. Here it is. We better take this away. Loosen up the screw. And again, I'll just bring this out here, like this, until it touches. Alright, we take this setting. We don't care. We go ahead straight at 0, which will be 0.5 on the dial. We go ahead and take our first step. Right. Let's take a measurement. .1. Same as the other side. All right. Let's see. I think we need to go up even further to check for the depth. This time we only made a very small and intricate ridge. But it's feelable. Yeah, 4.5 will be fine. We go back to 0 and lock the cable. Alright, so exact same as before, 4.9 revolutions. Take a half. Now this time I take a broom washer. So I don't get confused. Oh, I could show you something like that. Because we also do have We also have bore calipers. Let's go ahead and put them to use today. We're right at 27.7, I would say. 27.7. Wait. Yes, 27.7. 27.7, so we're at 28.7 with this one. Let's confirm that. Little bit more than 7. 28.7. All right. Now we have 1.1 mil to go. So we take another 1.1, which would be 550. 550, which would be 25.5. Let's take this one, and the next one we're gonna do the 550. Check another one. Oh. Yeah, 29.12, 2.5, maybe 3, and we need 9. So let's go ahead. All right, this should do. $29.9, 85.9. Let's see if it fits. I think this might want to have a little bit more clearance. No, fits right in there. All right, we're done. Bring back the boring head so we can use it next time. we won't be able to get it up, so as we're done we can crank the table down. We could have also cranked it out, but we didn't. We didn't think of this as we started. You can't always think about everything. And many options. You have like leaving this pen on the table so it dries out, gives you the option to buy a new one in the color you like more. Yeah. Let's break down this setup, clean them off. All right, use the deburring tool again. I'll put it right here. All right. Just quickly, I'll show you this part. These are the pockets we milled. Right in here. Yeah, this part is done. Maybe in the end I put up a couple of pictures and show you where this part is built into and how it works, so you might have a better understanding. But now all that's left to do is clean up this mess. It's awful. Complete the saw, and yeah, we're gonna hear us and see us next time. Thanks for watching.